So we talk about relations that they're not ideal. They have some problems, some redundancy that potentially creates update, insert, or delete anomalies. And we talk about that the solution is to decompose them into relations that have less redundancy, so therefore they have less of these anomalies, or potentially they don't have these anomalies. Let's be a little bit more specific about what we mean. And so let's think about this as the universe of all relations. You might remember from our first lecture that I said that the relational model is concerned with a special type of relation called 1NF, first normal form. So in first normal form, every attribute is atomic. That's the fundamental definition. So our course is concerned only with the relations that they are inside this circle. So any of the relations we have talked about so far in the whole chapter of this of functional dependencies fall into this category. All of them are 1NF. However, some of these have more problems than others, so we need to subdivide this set. Inside here, there's another subset, and as you can imagine, that is called 2NF. What does the NF stands for? Normal form. So second normal form. First normal form. This set is not very interesting to us, 2NF. So 2NF, we basically ignore it. We don't care for it. We don't define it, and it's not very useful for our purposes. There is another set inside here that is 3NF, third normal form. This is way more interesting, and we'll see actually why as in this segment. And then the ideal one, the one that we wish that every relation satisfied, is inside, is a subset of 3NF, and 3NF is a subset of 2NF, and 2NF is a subset of 1NF. So this new set, we are going to call it Bcnf. Boys caught normal form. These are our best types of relations. If we are able to design a database where all the relations are Bcnf, that's great. That's the ideal. Unfortunately, it's not always possible. So we will be happy if our databases are composed of relations that they are all at least 3NF, and the majority hopefully to be Bcnf. Okay, so that is the goal of this. So the fundamental idea is that if I give you a relation that is in 1NF, that's bad. We want to break it apart. So we want to decompose it into 2 or maybe 3 relations. All of them that they are 3NF or Bcnf. Okay? Remember, a Bcnf will be also 1NF. So still a relation that our relational database system can be able to deal with. Okay? So that is the purpose of this rest of the chapter, and this is known as normalization. How do I design databases in which all the relations are either Bcnf or 3NF? My starting point is relations that I derive from the specifications from my customer. And then I do my analysis and I determine that, they're not 3NF. They're not Bcnf. So then I have to decompose them into 3NF or Bcnf. So that is the goal of the rest of this chapter. So to be able to do that, then we need to define what is 3NF, what is Bcnf, and if a relation is not Bcnf or is not 3NF, how do I break it apart? How do I decompose it? A good decomposition, one that is functional dependency preserving and lossless join, that into 3NF or Bcnf relation. So that is the goal of this chapter. And let's leave it at this, and then I'll continue in the next video.